If you're not familiar with Rector Seal, if you guys heard of Rector Seal before you signed up, I see some noddings. That's great. We're held by a company out of Dallas, Texas called CSW Industrials. And they hold the umbrella for a handful of other companies. One being Rector Seal, another being Balco, which is a local company here in Wichita. Smoke Guard, if you're familiar with them, or I should say Balco, they make expansion joints and photoluminescent products. Smoke Guard, they are out of Boise, Idaho. They manufacture smoke screens and smoke curtains. So on an elevator door, if excessive heat or smoke was detected in the building, it closes a curtain down over top of the elevator door, so smoke either can't get in or go out, depending on where it's at. Unique products like that. And Greco aluminum railings, they're a recent acquisition with CSW Industrials. They manufacture aluminum railings for projects out of Windsor, Canada. So what I do is I work with architects and engineers throughout the country for two of those companies, which is Balco and Rector Seal. And then there's some rumblings about me getting Greco as well. So that could happen. Never know. So, a couple of things that Rector Seal manufactures other than fire stopping, and that's why we're here. Just so you know, they make a thread sealant, which is that bucket that has the number 5 on it. That was the first product. So that must be the fifth generation of their thread sealant. But what happened was, in the 1930s, oil was coming out of the ground in Texas. And since we're a Houston-based company, what they did was they screwed an oil valve on top of that steel pipe. Threads weren't very good back then. So Mr. Rector created a thread sealant and started the company, and that stopped the leak. So that's what started the company. And then we make primer and glue for the PVC industry, so you can glue pipes together, or the flux, so you can sweat pipes together. So that's kind of the background behind Rector Seal. But what we're here to do is talk about the construction division of our company, and that's where fire stopping is. So here's our objectives. We'll run through these objectives fairly quick. It's about 40 minutes. I also have some parts and pieces we'll pass around. They are safe to handle, although I have been bitten by a burr on this one because it's a piece of stainless steel. And every once in a while there's a burr that sticks through there. I did check it, but you never know. All right? So, most people equate fire stopping material to a red caulk, or as I refer to it as a red goop in a bucket. And that's really what you see a lot of times on jobs, is red materials. But what they don't do is they don't test just that material. They test everything around it, so they test a system. So they'll have to build a system. For example, on this photo, you'll see walls, floors, construction joints. They don't have a curtain wall on there, but it's actually tested as well. But they'll build one of those systems right there. So for example, a wall, they'll build a concrete wall or a stud wall. They'll cut a hole in it, they'll push a pipe through it, they'll fire stop it. And that's what they test. They'll test the entire system. So really what it is, it's our obligation to get a fire rating back to something that existed originally. So you have that stud wall, it could be a 2-hour rating. They cut a hole in it, now it's a 0. Now you have to fire stop it. So we have to bring it back to a 1 or a 2-hour rating, depending on what you guys specify, or what you're looking for. So, not all materials in our industry are red. We actually have 7 latex caulks. There's 7 different colors, but they're all a form of red, but we also offer white. We also offer beige. There are other colors. We have competitors that have blue, that have yellow, that have green. There's black. It can be any color under the rainbow. The inspector cannot walk in the building and say, okay, I'm looking for red. Well, it's a dead giveaway that it was a guy doing it, because a woman would have read the instructions first, right? Of course. And so now they didn't look on the submittals and say, okay, now I'm looking for purple stuff on this joint and this joint and this joint. And then I'm looking for yellow material in these 3 penetrations. So they have to do that. They really need to do their homework. And it's no offense if any of you are inspectors. But it's all on the submittals, all of the information about what's being used. So it can be any color under the rainbow. Just so happens red is the most popular color. So now here, you have some of that red material going around a piece of conduit. You have it being sprayed at the top of a wall. A couple types of material here. What you're looking at is an elastomeric caulk. And what it is, it's a very high temperature caulk that is very pliable. So it can stretch, it can compress, it can move around. As you can imagine, a plastic pipe is going to, as it heats up, it's going to become a little larger. As it cools down, it can decrease in size just fractionally, but it does that. So all of these materials have to adapt to those changes in size. So they call that an elastomeric type of product, where it's sprayed at the top of a wall. That material has a mastic built into it, so it's a different caulk than what's going around this piece of conduit. So that's a different, that's a number 1200 in Rector Seal's language. But it's a different material because now it has that mastic built in. As you can imagine, that floor slab is going to deflect. And so now that material has to be able to stretch and compress and remain adhered to the substrate. Because if it peeled away, now you have an avenue for flame and smoke to hop through the wall or the floor. And in our industry, of course, that's bad. So a couple different types of material there called elastomeric. Another material in our world is called intumescent. So now intumescent means to increase in size with heat. And so there are fire caulks out there that have flakes of this material inside it. So now I don't spend 45 minutes talking about that stuff. We spend time talking about this kind of stuff because these are the newer items in our industry, and that's what we'll take a look at today. This intumescent layer is the basis of a lot of new products being manufactured. So now it's a 1.5 millimeter layer. It's flexible. The ASF provides the latex, makes it flexible. And then companies add their components to it to make it a fire-stopping product. And that's graphites and silicons and things like that. So now if you add 325 degrees to ambient temperature, so about 400 degrees, this material will grow 30 times its size. So now I have 3 kids, they're in college. 2 of them graduated in 2 months. That's pretty cool. I get a raise. But the other one just cost me more. She's in the medical field, so I can't wait for that. But anyway, they go, hey Dad, what do you do now? Because a few years back I changed jobs. I went from the glazing industry into fire stopping. So I explained it to them and they thought that was kind of boring. So I said, well, that's okay. So we took out the turkey fryer in an old saucepan and I took a couple of strips of this material. We lit the burner and let it heat up, and then we took 2 of these strips and threw in the pan. And they immediately ruined the pan, but it all gushed out and it grew 30 times its size. Well, they thought that was pretty cool. So that got me back into the racing with my kids. So if you do put a lighter to it, it will grow about 1/2 inch. But I don't see smoke alarms. They're usually higher. Yeah, there it is. But if you do want a little sample of this or any of the parts and pieces that I have up here at the end of the session, please take them. Makes my luggage lighter. But you can take this home and do the process I did, or just take a cigarette lighter or a cigar lighter, works a little better. But you'll notice that it'll turn into a carbon char, and it'll actually grow. Now, it'll grow about this much, because there's just not enough heat around the item to make it grow sufficiently. But about 400 degrees, this material begins to grow. So where do you use it? A couple of different places. Here we have on the left side of the screen, there's 2 concrete joints coming together. So you have a construction joint. I have 2 concrete walls. 2 concrete walls coming together. So you have a construction joint. They take this material and all they do is stuff it into that joint. It's friction fit. So now, after that, they seal over top of it. So usually backer rod and a sealant. Doesn't matter the sealant. A DAP, Sikaflex, those types of products. But that's your seal. This will stay in this state until called upon. So now, the heat increases, there's an issue in the building. This will flood that joint with that carbon char, and that will cut off the avenue for flame and smoke to hop from compartment A to compartment B. So, single-sided application. Where in the old days, that concrete wall, you had to treat this side, so typically you would tuck mineral wool in there, then you'd spray the joint with a bucketed material, the red goop. Then you go repeat the process on the other side of the wall. So you were double duty. This, you don't have to do that. Single-sided application gets you a 2-hour rating. If you need 3 hours, then yes, you're treating the other side of the wall. But 2 hours right out of the gate. Another application, wrap it around PVC pipes. Same thing happens, the heat increases, this material grows. But it's collared by all of the material around it, sheetrock, concrete, doesn't matter. What this will do, this will collapse the PVC pipe and then fill the void completely. And that cuts off the avenue for flame and smoke, a hot tube flow. This gets very sticky when it gets hot. That's kind of like a rubber pan also. But we were throwing it in the heat. But that's what makes this material stay in place, is because it becomes very sticky when it's hot. When it cools, it's quite the opposite. It's a dry dust at that point. Almost like burnt newspaper is what I equate it to a lot. So, lots of applications for this material. I'll go ahead and send that around. You'll notice on the back side of that material, it's a foil backing. That's for manufacturing purposes, because this material is pulled through a die out of a large tank, pulled through a die. When it goes through the die, it marries the foil. And then they put it on a curing rack that's very long. It sits on that rack for a couple of weeks. And then once it's cured, they strip it up off the rack. And that's where that foil comes in handy, because it strips off nicely off the curing rack. So that's the reason for it. Can you wrap it around this way, or if my fingers would bend the opposite direction, you could flip the piece around and wrap it around that way? Yes. It does not matter which side of the material is facing in. It's always a friction fit product, but very quick, very easy to install. A couple other applications. These are collars and sleeves. The collar on the right, you can see that black line on the inside of that red ring. That's where that intumescent material is. So it depends on the size of the collar. Depends on how many revolutions of that material are going around the side. On the other side, you have a sleeve. Nothing more than galvanized metal with a couple layers of that intumescent material inside there. Very quick, very easy to install, because in this application, all the installer had to do was walk up to that pipe, wrap it around the pipe, slide it into place, secure it, and they were done. If they needed a better seal, then they'll take a fire caulk and run around the outside of that sleeve. Gives a nice smoke seal as well. And that's what 4B is right here. They're actually running some fire caulk around the perimeter of that sleeve. Installers tell people they can do that 8 times an hour, install a sleeve. The same installer said they can do that 1 time an hour, install a collar. Because before they put that collar on, they had to plug that crown with mineral wool. Then they take 2 pieces of sheet metal, they cut U-shapes in them, they surround the pipe, then they Tapcon that into place. Then they can finally put on the collar. 1 time an hour off the top of a ladder. So they can either walk up to the pipe, or they can work off the top of a ladder. And so these efficiencies come into play 8 times compared to 1 per hour. Putty pads. You guys are familiar with putty pads? I don't travel with one. They're really sticky. They don't have to heat up to get sticky. So it is a piece of putty with 2 pieces of paper, 1 on each side. The installer will strip off the paper and then begin to swear because it's nasty and sticky. And they'll wrap it around the back side of an electrical box. So you're going on the back side. You have to install that before sheetrock is installed. So really it becomes encapsulated. Or you can install an insert. So these are intumescent products. It's a peel and stick. So now all they do is take the sticker off the back side and place it inside the electrical box. And that's it. Standard box, doesn't have to be a deeper box, nothing like that. But this is for a double box. They're also made for singles. So this little insert takes 3 or 4 seconds to install. And that's it. That putty pad takes about 3 or 4 minutes to install. Before everybody else shows up, you have to install it. If you put this into place, you don't have to get there before sheetrock. It's after the electrical rough-in. Many times, these are installed in the electrical boxes before they even show up on the job site. So those things are offered by certain customers. Very quick, very easy. If they don't install that insert prior to the electrician showing up, the electrician showed up, put all his plugs and his wires and everything inside the electrical box. You don't have to go strip all that out just to put the insert in. You can use a gasket. Same material. And as you can guess, that's for a double switch. But all they do is remove the cover plate, put this on, put the cover plate back over it, and they're done. So it's a matter of moments.
So what does it take to make that reactive? I mean, is it, you said 400 degrees?
Same thing.
So
Same exact thing. Same material. All they do is they compress it down a little bit more for here so it can fit nicely underneath the cover plate.
Nice.
Where they don't have to worry about that with the insert. They'll flow the material a little bit heavier onto the curing rack. And then that's actually run, it's a more narrow curing rack. It's about this wide as opposed to that intumescent layer. It's the curing rack's about this wide, has little bumpers on the side. That's a little different because they'll do the width, and then when they strip it up, they cut it, make a nice clean edge. But then they'll run it through a wheel that has all these blades all the way around the wheel. You just hear pop, 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 pop. And that's cutting those to length.
So it obviously blocks the holes from other conduits going out, but does it snuff out the fire? Is that what its intention is?
Absolutely. Here on the lower right-hand corner, you'll see a picture of that electrical box with an insert in it. It's under duress. You can see it glowing. It'll take the path of least resistance. So it's going to flood every part of that electrical box first. Because, you think about it, it's going to have outlets and switches and wires and then a cover plate on. So it's going to smush into that area first. And then if there's a conduit tab removed, it'll push out of the conduit tab. If there's a piece of conduit connected to it, it will race up the tube until it's exhausted. But yeah, it just takes the path of least resistance. It goes everywhere. That's why you want to contain it. That's what makes these things very attractive for electrical boxes.
You do that in a sheet good, because I know we've had questions about a lot of recessed monitors and walls, rated walls, and not having to build out the construction behind there. I know you can't use multiple putty pads to get around that. But it seems like something like this, you
Yeah.
take care of that entire opening.
Yes, service panels and things like that, sure, absolutely. When I removed my AIA hat and put on the Director Seal hat, which I just did, yes, we have a UL system specifically for that, where they use the intumescent layer in specific widths, and you wrap the perimeter of the box in that material. So then the electrician's trying to poke a wire through. And I go, well, what's this? All he does is just takes his screwdriver, punches through the material, and then guides the wire through. But yes, we have systems that do that. The material lays in the back of the box as well. If you want to do that, you can perimeter, or you can put it on the front cover. I don't like that because everybody writes all the stuff on the front cover. We just cover it up with stuff. Yeah, so that's no good.
So when this reaction actually happens, is it a loud, silent? I mean, what is that? I'll ask because
Yeah, no, I
I have
understand.
a childhood experience. We, when I was about 6 years old, we had a house burned down from just that, an electrical box on fire and caught the wall. So I guess, but that electrical box was hidden as well. So and it was in the kids' room. So my question is because would we know that if, that a fire came through there and reacted and,
Right.
whatever?
Right. The sound that it gives is a hissing sound because it's a latex product, which is water-based. So now the water's still there when it was made, formulated. The water's still there. And what it's really doing, it's hissing that. So you do see some steam coming off of this when it's burning. It didn't pick up in the photo, but it will steam. And any intumescent product will do that. But yeah, you just hear a hiss is all it is.
Like the snakes at 4th of July?
That's what I was
Very similar. Very similar.
Yeah.
The
Just
only-
not on fire.
Yeah, the difference is those snakes will have their own fuel source, where the fuel source for this material is heat. So as soon as you remove the heat, the reaction stops.
You need to have a trailer there to the seminars.
Say that again.
A trailer that you go around
That'd be cool.
Administrations.
Yeah, and what I should have is the large board that has all of these items in it, and I could, do that, but AIA kind of frowns upon that because it's got our stickers and logos all over these things.
No, we want to see fire.
Yeah, they're gonna burn something. Now, if you want to do that, if you go to Houston, we have our own test lab in Houston. It's separate from our plant. It used to sit next to our old plant, and then we outgrew it, so they rebuilt, I think, closer to the executives' houses than where they had it originally. So they had less of a drive in the morning. But yeah, you could go down to our test lab in Houston and witness that. Yeah, next week we have 46 people that we're bringing to Houston to train. And then you sit through class time and a lot of stuff on the first day. The second day, in the morning, you drive down to the test lab and you witness a burn. So when you get there, the wall's already cooking.
Yeah.
Yeah, yeah. And they go through the whole test. And I'll show you some pictures of that in just a few minutes in this presentation. But yeah, that's what these little guys will do. So now, a lot of times I'll get a question about price, because new items always seem to be priced more. You buy a new computer, it's more, and then they chunk down in price. Same thing probably happened with this, except I'm on the beneficial end of it, where these things are inexpensive now, because that putty pad is $5. The double insert is $4. This guy's $3.75. So the new technologies are less money, they're faster to install, they're cleaner, they're easier, and you don't have to buy a new pair of gloves after you install these, as opposed to the putty pad, because they're all sticky.
So why don't they all use that? I mean, that seems the easiest and cheapest.
Correct. Everybody always uses the putty pad. I mean, and now we're seeing the trend change, and that has been for the last several years. But it's education.
Yeah.
Exactly what I'm doing here. Did you know about this before I
I
showed
have
it
no
to you?
idea.
Exactly. Yep. So you walked into your fire stopping RS store, and they didn't have these on. They didn't have these on the right shelf.
Right.
They had it on the bottom shelf or something, or they may not have purchased them at all. Electricians like these a lot better than doing putty pads if they are the ones doing the fire stopping. So there's ways of for architects to write that out, to have a specialty company come in and install these items. But yeah, the last thing a plumber or an electrician wants to do is fire stop after they get their job done. And that's what they have to do. And in shifts, because they have to install that first. Here's a mortar mix. It's just a dry powder, cementatious material that comes in that bucket. And then they add water to it on a job site. And you can see that cable tray going through the wall. They had to put a form up on one side, they pack all this material in there, and then they put a form on the other side. So they can have a nice flat appearance, make it look good. That's fine. You could use that, or you could use pillows. Pillows are wonderful. Nothing more than a bag of mineral wool and a couple layers of that intumescent material inside a red bag. We know of people who have taken and opened up the red bag and started stacking these in. And they said, well, what do you do with all the black layer stuff? And they said, what do you mean? Why'd you know about that? And they said, well, when we opened up the bags, and we stopped them right there and said, wait a minute, you can't do that. It has to remain in the bag. Because you'll stack all these things in like bricks in the area, but it's an intumescent product also. So now the beauty of these, if you had to run a pipe through there, you pull out the bag, you run the pipe, you stuff the bag back in. These are fine. But now there's a composite sheet that's created. So instead of buying lots of pillows or lots of mortar mix and coming back 2 days later to remove the form, you can use a composite sheet. And this is a stainless steel layer. On the other side is that intumescent material. And it's bonded together. They foil wrap it. This is manufactured 3 feet by 3 feet. Other companies have a cementatious board. It's about a 1/2 inch thick. Same thing. They'll layer the intumescent material on there, and it's all bounded together. And then they'll run that through a table saw to cut it. Where this, you can use tin snips. You can bend it with your hands. You can put it into a break, get a nice bend on it. Any size, any shape, 3 feet by 3 feet or less. Pretty sure there's no burrs on that. But very quick, very easy. So now, in this case, cable tray is still running through a block wall. They routed the opening, they mounted Tapcon, the composite sheet to the wall, and then they run their wires through it. And then they sealed up with a putty stick. And that's what the red material is, for a good smoke seal. But quick and easy. The intumescent layer faces in, and it gives you a 2-hour rating. And you don't have to come back. One person can do it. Quick and easy, they're lightweight. So now if you have larger openings, you can gang these things together. A 2-inch overlap, mechanically fastened. You're ready to go. Sheet metal screws, that's it.
Looks like that one's got a tag. Is there a tag or something that tells the next guy that's coming through there, the inspector?
Could be. Could be something like that, yeah. I'm really not sure what it says. When I tried to blow it up a couple of years back, it just distorted, so I couldn't, I did not recognize what it said.
It would be good if those were labeled though somehow, so that
Inspectors.
with red text.
The next
Now,
contract.
those are produced. We do have tags that we send out by the stacks full on projects and healthcare. They want all of their through penetrations and joints labeled, and it has all the information. And I do have an example of that tag. You'll see it here in just a couple minutes. But if it's added to the specifications by the architect, that each through penetration and construction joint is labeled by the installer, then we have that ability, and so do all of the Firestone manufacturers.
So those pillows with the plastic wrap, are those smoked?
Yeah, they have a smoke rating as well.
Really?
Yeah, because what the instructions call for is for the material to be crushed a certain percentage, and that's what gives you a nice full seal.
You're talking about systems, so if I were to use the sheet metal stuff on an area that I've already tacked in the mortar and had forms on each side, we actually just left the sheetrock in place that we used as part of the form, but I could take that sheetrock off and put this over it. Would that have any I mean, would just provide an added barrier to make it look a little nicer?
Yeah, you could, the material is more for concrete wall and block.
It is actually a block wall.
Okay,
We just
great.
use sheetrock
Perfect.
as our form.
Gotcha,
As the
gotcha.
past, so.
Okay. Yes, you could. Yes.
And just, that would look a lot better than a sheetrock patch on a block wall with
That's
what's,
correct.
that's what they chose to use.
And then if they need to run another cable tray, run a pipe right through here, for example, all they have to do is route the opening, push the technology through, and then seal up with a putty stick. And you're ready to go. 2-hour rating on one side, add another hour if you put it on the other side. So you can get 3 hours out of a wall that used to be 4 hours. But most of the time it's 2 hours. That you guys are
What's a
looking for.
sheet of that 3x3 run?
It's right around 250. Of the things that you're going to see, the composite sheet's is the expensive one. It's the one that people go when they see the price on it. But yeah, it's it requires a unique manufacturing process, and it's kind of long and drawn out. And you have to take the material from one plant to the other, get it made, back, all that kind of stuff. So, but quick and easy. And on this large photo, you can see where they have the putty pads going around. These are actually pillows that they've stuffed into that wall as well. So a lot going on with that photo right there. I'm not moving. You didn't touch it, eh? I'll just do this. No, the computer's not moving. Locked up.
Your mouse moved.
Yeah, the mouse is there. I'm hitting the, there we go. Hopefully that did it. Let me bring this back up. Perfect. It was just thinking. So now, one last item. For top of wall. In the past, they would use a caulk material, and you'd have a floor slab and your top track and your studs and then your sheetrock. Once that was done, they would flood each of those joints with fire caulk. They could yield about 250 feet a day caulking. now you can use this 4-foot stick intumescent product. So it's nothing more than an intumescent layer in foam. You take this and you collapse it down, you set it on the top edge of the sheetrock, you let it go, and you tuck it in with a putty knife. So now this will absorb the movement of the floor, 1 inch, movement of the floor slab. So it sits there and moves around. Has a smoke rating, has a fire rating of 2 hours. Stays in place by compression, and that's it. But very new, this came out last year in March. Now everything that you've seen, all of the competition has their own versions of it. But that is a rarity.
How
The
much?
competition.
Linear foot.
Say it again,
How
please.
much a linear foot?
I don't know as far as per foot pricing. What they always want to do is compare with the labor. So now you have a little bit higher material cost on that, but you have a lower material cost on the caulks. But the labor is quite the opposite, because you can go 1,200 feet a day of that material as opposed to the 250, 300. Yeah, so I don't work with pricing because that's the sales guys' jobs. Yeah. But when you combine everything, you're looking around between $350 and $450 a foot installed, because it's so quick and easy.
It's the laminated side of
Yeah,
them.
that'll go down. As the instructions call
Okay,
to
and
go
then
down.
that's where-
Yeah, but it was tested both ways with UL, so we took it, and if they didn't read the instructions and they flipped it over and the intumescent material's facing up, it was tested that way and it passed as well. Yeah, those are some of those things that UL said, wait a minute, say they don't read the instructions. And they had a catastrophe. You know, so it did pass both ways. Yeah. You just can't lay it in flat.
That way.
Yeah, because there's just, I mean, there might be enough space, but as soon as that slab deflects, it'll fall out. There's that gap they like to keep between a 1/2 inch and 3/4 inches. Here's a curtain wall. The reason I show this is because of the fire caulk that they sprayed on there. So they had the concrete slab, the nosing, they stuffed it with mineral wool, and they came back and they sprayed a white fire caulk there. So now if you have an open web ceiling and you have to treat the top of the wall with a fire stop product, the installer can use white, because it's a lot easier to paint over white than it is red. So here's some numbers AIA said I had to tell you about. This is 147920, 792307. The numbers represent what UL said you will do when you're testing your assemblies, your systems. So one's for penetrations, one's for construction joints, the other's for curtain wall, is what that is. So they're going to tell us that you're going to test for 3 things. You're going to test for temperature, you're going to test for flame, you're going to test for water. The bottom 3 are optional. So a T rating is for temperature on the cool side of the wall. How long does it take to get to 400 degrees on the cool side of the wall? A W rating is simply a column of water sitting on top of the through penetration. Those are usually for silicone products. Then the L rating is leak or smoke. So, from the top down, temperature. You'll build a system. You'll build a stud wall. You'll cut a hole through it. You push a pipe through it. You fire stop it. You put it onto a burner unit. That's for walls. That's for floors. So right now they just lifted a floor system with metal pipes off of the floor burner, and they're glowing hot is the reason they're pink. But that floor system is about 6 feet by 4 feet is about what they did. On the wall unit, this is a 5-foot by 5-foot box. This item in the middle that looks like a speaker is actually a 2-inch gas nozzle. That's where the flame comes out. So that's the hot side of the box. We're on the cool side of the box. So back to temperature. You take that wall system, you clip it to the burner. The UL engineer hits go on the computer. The gas ignites and it starts to heat the hot side of the box. So you have 2 minutes to get it above 400 degrees. You have 8 minutes to get it above 1,000 degrees. If you don't do that, the UL engineer shuts off the gas and you flunked your test already. So that's the temperature part of the testing. raise the temperature in a timely manner. So now the next thing is flame. If we're testing a wall for 2 hours, for that entire 2 hours, the flame can't come from the hot side of the box to the cool side of the wall. It cannot hop through through penetration or any other part of the wall that's being tested. If it does, you flub. The other thing is the water test. If we're on a 2-hour test, you have to spray it with water for 24 seconds after it's been burned for the entire duration. So now they burn this wall, for example, for 2 hours. You have 10 minutes to get it from the burner over to the other side of the lab where they spray with a fire hose. And they have this certain pattern that they follow when they spray. And you can see the pipe is right there in the upper right-hand corner of the wall section. So they raised the temperatures in a timely manner, it passed. The flame didn't hop through the wall, it passed. And they sprayed it with a fire hose for 24 seconds to agitate the material. As you can imagine, that's a very hot item being sprayed by cool water. And when that happens, in many cases, it's bad. In this case, it's a good thing because we want to make sure all that fire-stopping material stays in place. So now you spray cool water on a hot item, you agitate the material, and after 24 seconds, they shut off the water. Then they take a light and shine from the back side of the wall. If they see any light coming through that wall, you flunked your test. So you can pass it on the temperature, you can pass it on the flame. You blow it on the water test, you don't get your UL on. So they're very strict. But as you can imagine, like I talked earlier, this stuff, these kinds of items, even the caulks and the sprays, they get real sticky when they get hot. And that's the good thing about it, because it's going to stay in place. So now here's the before and after. The before shot on the left, you can see just simply a fire caulk going around a plastic pipe through a framed wall. Actually, there's little speckles of intumescent material in that fire caulk, because it's an intumescent fire caulk. And all those little speckles heated up, expanded, collapsed the PVC pipe, filled the void completely, stayed in place during the entire test. So, neat stuff. PVC pipe melts at 415 degrees. So at 400 degrees, when the intumescent material starts to grow, that pipe is in a softened state. So all it did was just finish off the job. It didn't have to collapse this big, rigid monstrosity. So then you see on the right is the leftovers. So that's after it was sprayed with a fire hose. As soon as the smoke cleared, they took that picture. You guys familiar with UL letters and numbers? You have to work with these things. They did a great job. They actually mean something. So it's pretty cool what they've done here. So what I've done, I've taken a number and grabbed the charts off of the UL website. So now, this is for a through penetration. Walls, top of wall and bottom of wall, for example, in construction joints, have their own language, but it's very, very similar. But this is specifically for a through penetration. So now, that first letter is a W. We come over here to the chart. That first letter can be an F, a W, or a C. So it can be a floor, it can be a wall, or it can be a combination. Well, a combination is they took a wall or a floor and tested one of them, but it didn't matter which way they put them because they're made of the same materials. So they said, as long as you have the same materials, because UL was going through so many numbers and letters so fast, they had to punt. So they come up with a C. And so they said, well, okay, as long as it's the same stuff, it doesn't matter if you test it vertically or horizontally. So we can use C's or W's or F's. So in this case, they used a W for walls. You go to that next letter, it's an L. Here's that UL chart. You go all the way down to L and you look over, it's for framed walls. So now we know we're working with a wall that is framed, where it's not concrete, because if it was concrete, it would be an A or a B. So a WA is a concrete wall or a floor. You know, that kind of stuff, or a concrete wall, I'm sorry. So that's the first two letters. The numbers. That first digit, that 2000 digit, is very important because you can put up there WL 2000 and people in my industry know that it's a framed wall with a non-metallic pipe or conduit tubing going through it. So in other words, plastic pipe. We know that it's a plastic pipe going through a framed wall. Those next three numbers, 414, is just the number that UL threw at Rector Seal. in the time of testing. We're not always 414, but that was just the number they gave us. So that's what those things mean. Then they give you a drawing. They actually give you a JPEG, you have to create your own drawing. But you'll notice here, you have a point of contact. You see that pipe is all the way down against the sheetrock. UL's pretty smart. They've been on a couple of job sites. They know that's more reality than that pipe going perfectly centered through the opening with a near equal amount of material around the pipe. It's harder to test that way and pass. So UL said, since that's possible on a job site, you'll test that way. And that's what we have to do. We're handcuffed by them. We have to do what they say. So we do. So that's what they've done there. Lead points, the caulks and sprays, for the most part, are a latex product. And then manufacturers in our industry also have silicone products. They have hybrid products as well. But you can gain lead points, the most lead points, by using a latex product. These items are latex. Same way with the putty pen, if you have to do that. But all of those items are latex, so you can gain lead points using those products. Now, here's that sticker we talked about a little bit earlier. That is the sticker that we ship out and all the other manufacturers ship out and say, okay, what's going through the wall here? And they have to list out all the information that's on that tag. So then when the hospital goes for its annual or biannual or whatever it is, inspection time, then they pull down the ceiling tiles, they see all the items going through the wall, and they can tell who did it. So then if there's an issue, if the caulk is dried and is cracked or is crumbled away or something, they can go, okay, that was the system, whatever. It had this material in it, this company installed it, they have to come back here and take care of it. So that's what those stickers are real handy for. Specifications. You guys write your own specs. Some of you do, maybe. We're in section 78-400 is where it's at. Now, what you'll see on the specification from us or any of the other manufacturers, set up in a master spec format or a series of brackets. And you can look down from the top, but the second one down in warranty, there's with the major manufacturers, which are Rector Seal, Hilti, STI, and 3M. They're the four largest manufacturers or suppliers. And then the rest trickle in as well, Tremco, AD, and so forth. But that warranty line is pretty important because one of the manufacturers only offers a 90-day warranty. It takes longer to build a building than 90 days. So I don't know what they're providing the client when the general contractor does their closeout documents because one of the things that's required is a warranty. So they may turn that warranty over, but it's already expired at 90 days. A couple other manufacturers will list out a 12-month warranty. So a little better, but there's also a sustainable life of the building warranty, which is really nice. So as long as the building is standing and the material was installed per the instructions, then the warranty is intact. Storage and transportation temperatures. These are real important, not for this, but for the red goop in a bucket stuff. Because if you store that material outside its temperature range, the material separates. And it's not like tomato juice where you just give it a shake and it rejoins. No, the material separates, it's done. So you put it into a caulk gun, the first couple of pumps out of the gun is a liquid that runs down the wall. It's a dead giveaway that it was frozen or the material was in a temperature more than, for example, 40 to 77 degrees. It's going to be, what, 77 degrees this weekend here as we warm up? Yeah. So anything hotter than a beginning of March day in Wichita, you'd have to use something else. You could use the material that has a storage temperature between 35 and 120 degrees, which is a pretty good temperature range, and a very broad temperature range. Same way with installation temperatures. I was in Phoenix last year in June. It was 108 degrees, and I'm standing underneath a tree because that's the only way you can take it. But I noticed that if it gets to 109, then I just either want to go to the car or go back inside. Because 108 and below is okay in Phoenix, 109, no. So forget it. But we were out there, and it did get to 114 that day. So, the installers can stay working if you select the product. that goes up to 120 degrees because everybody else's cuts off at 104. Okay. And then there's other things, shelf life and stuff like that. But to let you know, Rector Seal is sustainable life of the building, and Rector Seal is 30 to 120 degrees in storage, and 35 to 120 degrees in installation temperatures. The best non-product offerings in the industry. Says something about the product that we manufacture in Houston. Okay. There it is, the 4 manufacturers, and then some of the others. If you still see W.R. Grace in your specification, let me know. I'll take care of that for you since we bought them, their fire stopping division, back in 2007. Okay, I still see their name all the time. They made a wonderful product, and now we make it. So now, the long and the short is, add Rector Seal and Balco, our sister company, to your specification. Make us your basis of design. To do that, all you have to do is just give me a shout. I'll take care of all of it for you. You can send me your drawings. I'll have all the drawings done, all the detailed drawings done for you. So then all your fire stop details are here in this pile. All your expansion joint details are in this pile. All the other things that Balco does can come along with it, like photoluminescence and entry mats and grates and things like that. So I can provide all of that for you. All you have to do is just give us a shout. So 3 things to remember. You can remember me as a resource for you for what I just explained. Okay? I only work with architects and engineers and some general contractors every once in a while. I support, right now, 4 outside salesmen, and they cover regions in the country. My region is the entire 48 connecting, but they have theirs split down. So I'll go into a firm, work with them, get our information on their construction documents, so that when it goes out for bid, people look at it and go, I need to get a bid from Rector Seal, or I need to get a bid from Balco. So that's what I do. Best non-product offerings in the industry. I just mentioned that. If your materials can't sit on the job site in the summertime and then be used, they're useless. They need to be replaced. Okay? You don't have to do that with the Rector Seal products. 120 degrees is what it goes up to. And then the new technologies. You don't have to specify that putty pad. You can specify this, or any of the other items. All you have to do is let me know. I'll take care of that specification for you. I'll write it 2 ways. One where we lock out the competition, pretty cool, or one where others can bid it. And most of the time it's the latter, not the former. It's where everybody else can bid it. It's rare when an architect asks me to write me a proprietary spec. Very rare. So, but I can do those things for you. So, that's what I have. There is literature up here for fire stop products. There's 1 catalog left for Balco. If you guys would like something like this, it has all the items that we talked about, in addition to the caulks and sprays that I don't haul those buckets around, but they're in here as well. They give you a brief synopsis of where they're used. So they did a nice job putting this together, saying, okay, you use this at top of wall and bottom of wall. You use the other one for through penetrations on plastic pipe, and this one for metal pipe, that kind of stuff. It's all in this catalog. If you need any information, my business card is here as well. You can just shoot me an email, and I'll take care of it for you. Okay? Appreciate your time and your attendance. There is a sign-up sheet if you came in late. The sign-up sheet is on the back table. Just write your information on there. I don't have anything to do with that, but I asked them to save it to you. So, what do we have? I like Pluto, so it's an honorary planet with me.
I was literally going to ask that question.
Yeah. I grew up the entire time. Pluto was a planet.
It was a planet.
And then they yanked it away.
They did.
So, yes, now, maybe it'll come back. Maybe.
I thought they were talking about bringing it back.
There
And then there's
were
another
rumblings.
one now.
Yeah. There were rumblings and then that one.
It is a planet. And
Yeah. So, you can see that there's lots of options available. Many of the things that we do with, I should say, one of the things that we do, thanks, with this item, on the Balco side of our business, we send this product over to Balco and they put it in their expansion joints. So if you see the intumescent layer being used in in an expansion joint, and this is it. This is it exactly.
This stuff reminds me of like the phone you'd put over a stereo speaker or something, and it only has about a 10, 15-year life if you're lucky.
In speakers, yeah. You gotta turn the music down, that's what my wife told me. Yeah, because I had to replace the around the perimeter of the speaker.
Yeah, so,
Yeah,
but did you say you cover this with cotton?
you can.
Or
Yeah, you can, with that material, because it's black, charcoal. We've had some pushback where they say, well, my wall's white, and now I have this big black line going across there. And we instruct them, you can spray that with a latex caulk. It still maintains its flexibility.
Okay.
They can also mud and tape over it. That's okay, but the problem with that is that floor slab's gonna deflect and hammer that mud and tape, and it's eventually gonna pure out. Where if they spray it with the latex.
And so the movement probably doesn't prevent it from getting brittle still though.
Very
So,
possible, yeah.
you know, buildings designed for 50 years plus, you think this is going to be replaced?
Well, our warranty is sustain the life of the building.
Okay.
So if 20 years down the road, 30 years down the road, if there was an issue and that was still installed, yeah, we're going to replace it. Absolutely. See, the way we test with you, and I'll get to your question.
That's why,
Yep.
yeah.
Yep, the way we test that's different than everybody else, you have to simulate the aging of a product with intumescent items. So we have to put this into, it looks like a big pizza oven, is what it looks like, but it's a chamber with a big door, and it's an oven, and they put all of these materials into this chamber. They shut the door, they turn the heat on, and it brings the heat up to 158 degrees. It sits in there for 9 months. That simulates 30 years of aging. UL said you only have to simulate up to 6 years. Well, that's like 3 months in the oven. But we don't do that. We let it cook for 9 months. So we know what it's going to do down the road. Since we've been around since the 30s, but in fire stopping since the 80s, we've taken material and stored it. And it still sits in this test lab down there in Houston. And every once in a while, I'll grab a tube and test it. You know, it'll be 10 years old, it'll be 15 years old. And they'll still test it, and it still passes. So the way we simulate the aging, because UL said you have to, we do it more than the test. And so now that's why we know what it'll do 30 years down the road. Because they can just let stuff sit in there and bake forever. Take it out, test it, and it passes. Yes, sir?
As a foam material, I guess is a lack of a better term for it than that, as it heats up, does it off-gas? 'Cause a lot of your,
It does.
okay.
Yeah. What those numbers are, I don't know, because what it can do is be toxic.
Yeah.
Yeah, so it's a material that is
Well, that's what I was thinking
on the
about,
lower
the
edge.
healthcare environment, and
Correct.
using that product, and that off-gassing can be an issue, and I
Correct.
didn't know if you guys have studied that or not.
Yes, and because it's still a latex product and offering lead won't let you do that if the gases are so obnoxious. Yeah, so I don't know what those particulars are, but yes, that was considered and taken into consideration and said, no, you will not. And so, yeah. But these products are all made, I was about to say here in Houston. In Houston is where these things are made. So that's different than our
Are
competitors.
there any markings or identified, if I walk on the site and see this product, is there something that's gonna tell me this is a Rector Seal product if I encounter it versus just foam? I mean, is there anything that
Yeah.
distinguishes this?
Other than if they took that yellow tag and marked it. There isn't, because, you know, it quite literally comes out this way. You know, this has the name on it, on the foil, but, you know, and it's on here. It is on here as well, but not
That's
this.
other foam.
Yeah, no. It may be something where they want to do that in the future, but we'll stick to that. You know, what does it then do to its ability to expand? Does it hinder it in any way possible? All those things have to be taken into consideration.
Well, and I think the reason he's asking is it's something I've run into fairly recent on a project, is where you specify a quality level of a component. And this is
I don't know what
hardware.
I'm getting.
And you have
Not me
a
checking.
contractor that will actually take an inferior product out of the box and put it in the box of what we specified to use it on the job site.
Yep. Absolutely. It's very costly.
And other than when it failed, we didn't know until it actually failed before they finished the project, or we would have been in a world of hurt over it.
Or one of my facilities guys is gonna be running a new pipe through there, he's just gonna pull that stuff out, because he doesn't know.
Right.
Yeah,
There's no idea, if it's got red goop on it, they usually say, okay, well, that's.
Exactly. Everybody in this world equates it to the red goop in the bucket. That's exactly it. Yeah. But any color under the rainbow it can be, and it is many colors, but it's just not every color, but it can be. So nobody says it has to be red. If the inspector walks in and says, I'm looking for red, if I don't see red, you flunk. Buy him lunch, because, and show the door, you know, because he did not do his homework. And there is no law, no municipality that says it has to be red. Does not exist. Yes, sir.
The foam product that you passed around here, have you ever thought about roll that out, you know, to the airline industry or the aviation industry? Because it's lightweight, it's bendable, fire retardant. I mean, especially on some of the wiring harnesses.
Yeah,
fire
and plus, it can ride along the contour of the fuselage. There's one problem. Our warranty, I believe, there's somewhere that I read, it has to be a land-based structure with our products. I don't think it's in the warranty, but I read that somewhere. But,
Which
I
can
mean,
be
because
changed.
it's so light, that this would be cool in the aviation industry. And this being, Wichita being a hub for manufacturing, it could be. Tony's over there writing this down right now, going, hey, wait a minute, I might have you a side gig.
Just
Tony's
to
with
tell, I'm
Valco.
a pilot, and I,
Are you?
yeah, I
Okay.
fly a lot, and I don't do maintenance, I'm not an FAR repairman, but I just can see some applications, you know, the fact that it's fire retardant, it's flexible, and it's lightweight.
Yes.
I mean, it's just a thought.
Very lightweight. That's the thing. Yeah, this comes in 4-foot sticks, is what they do this in. But, I mean, and when we ship it, it's just shipped flat in a box. But they don't roll it or anything, so it comes out nice.
Well, what's the melting point of aluminum or composite?
Aluminum is around 1,400
Oh, is it?
degrees, yeah.
Oh, okay. So it would expand before you got it.
Yeah, it would expand out and stop well before that. Yeah, and glass and all that kind of stuff, because when we test with curtain wall, the curtain wall, at the end of the test, the curtain wall melts. The glass is already gone. It melted out or it blew out, one or the other. But yeah, the verticals and the horizontals are there for a period of time, and then they just begin to distort and
Right.
go away. Yeah. It's a pretty cool test. Expensive. Yeah, they're like 60 grand a shot. That's why manufacturers don't have a lot of curtain wall UL systems. They will do an engineer judgment, because the moment you change one thing with UL, you test it. So if everybody used a 1600 Conair system, and that was it, then it'd be okay. We had it covered. But now that there's Wausau and El Paso, each of them have 18 different systems. You have to retest. So we do EJs, engineered judgments a lot for stuff like that. We do more EJs for curtain wall than all the other products combined. And it's always different. I came from the curtain wall industry. That's my background is glazing. And fire stopping was always an issue. Our drawings said bio, our drawings always said fire stopping bio. That's as far as we can take it. Yeah. What else do we have? Unique stuff. Something that's why I don't have buckets up here. I wanted to show you guys the new items in our industry. So that's why they said, yeah, Scott, come on and present here. So, thank you very much. There's stuff up here if you need it.
Nice stuff.
Please, thank you very much. if you need it, go ahead and take my card, shoot me an email if you need something. I go wherever United Airlines takes me.